Have you ever stopped to wonder how computers actually make sense of all the information on the web? I mean, it's not just about what we see on this screen, right? There's this hidden layer, a really simple but powerful idea about structure and meaning. And to really get it, we need to look at the difference between two fundamental languages of the web. So just take a look at these two little bits of code. On the surface, yeah, they might end up looking pretty similar on a web page, but what's the real difference here? Well, one of them is basically just telling the browser how the text should look. But the other one, it's describing what the text is. And that little distinction, that's the key to this whole thing. And that really brings us to the core question. What's actually in a tag? Is it just a command for how things should look on the page, or can it carry a deeper meaning? This isn't just some techie detail, you know? It's the difference between a computer just showing you information and a computer actually understanding it. Okay, so let's start with something we're all pretty familiar with, even if we don't realize it. HTML. That stands for Hypertext Markup Language. It's the skeleton of pretty much every web page we see every single day, and its main job is to tell a browser how to arrange and display stuff. Right, so the most important thing to get about HTML is that its whole purpose is to describe the layout of information, not what that information actually means. It uses a set of predefined tags that it already knows. So for example, P just means make this a paragraph, and H1 means make this a big heading. They're all about presentation, how the data looks, but they don't say anything about what the data is. To a computer, it's just a headline and a paragraph with no real meaning attached. And this example right here really highlights that limitation. Look at the HTML side on the left. We see those H2 and P tags. Now a browser knows exactly what to do. Make a headline and Ford Mustang a paragraph. But the browser has no clue that Ford Mustang is the make of a car. That specific relationship, that meaning, is completely lost. And this is where our second language comes into the picture. XML was created to solve this exact problem. Instead of focusing on display, its entire purpose is to describe the data itself, to tell a computer and, well, a person, what things actually are. XML stands for Extensible Markup Language. And you can just think of it as a way to wrap your data in little descriptive labels, labels that explain what the data means. It was designed from the ground up to structure, store, and transport information in a way that is totally self-descriptive. And this, right here, lays out the core difference perfectly. HTML is all about displaying information. XML is all about carrying information. HTML has a fixed set of tags. You can't make new ones. But with XML, you can create your own. And honestly, that changes everything. This brings us to what is easily the most powerful idea behind XML. That X stands for extensible. And what that really means is you are not limited to some list of tags someone else made up. You get to invent your own language, one that's perfectly tailored to whatever data you're trying to describe. I mean, this quote from the source material just says it all. The real power here is that anyone, a web developer, a scientist, whoever, can create their own custom tags to fit their specific needs. If you have a unique kind of data, you can create a unique tag just for it. So what does that actually look like in practice? Let's build a really simple example together, right now. Imagine we want to structure the data for a recipe. We can just invent a main tag to hold everything. Let's call it recipe. That's our starting point, our root element. Okay, so we've got our recipe tag. Now, inside of it, we can add more specific tags that we also just invent. To describe the name of the recipe, why don't we create a name tag? Perfect. Now, any program that reads this file knows exactly what simple pasta represents. And we can get even more detailed. Let's add an ingredient tag. But check this out. We can also add attributes right inside the tag itself, like amount and unit. Now the data isn't just structured, it's incredibly specific. It's self-descriptive. Anyone or anything can look at this and understand that we need 200 grams of pasta. So inventing our own tags for a recipe is cool and all, but why does this matter so much? Because it creates a universal way for totally different computer programs to share and understand data. It becomes a kind of universal translator for information. And here's pretty much how it works. Imagine one program writes some data using a shared set of XML tags, like our recipe tags. It then shares that XML file. Now, a completely different application, maybe one built by a different company years from now, can open that file and instantly understand its structure and meaning.
Why? Because the tags tell it everything it needs to know.
And this idea is used literally everywhere. Entire industries have created shared XML vocabularies to standardize how they exchange information. You've got MathML for math formulas, CML for chemistry, XBRL for financial data, and RSS, which you might have heard of for news feeds. This was a revolutionary way of thinking, and it really paved the way for things like modern web APIs and the countless configuration files that run so many of the apps we use today. So, when you put it all together, this gives us a completely new way of looking at information online. It teaches us to see past what's just on the surface and to think about the invisible structure that gives it all meaning. So here's a little takeaway for you. The next time you're using an app or browsing a website, just take a second to think about the data you're seeing. Is it just being displayed for you to look at? Or is there a deeper structure underneath it all, a quiet language of tags that lets the computer truly understand what that information is all about? Because in the end, that's the simple, elegant idea at the heart of all this. Structure is what creates meaning, and when we can agree on a shared language to describe that structure, we create true understanding, not just for us, but for our computers too.